I have an update to the weird bright spots seen on Saturn's largest moon, Titan. That story was covered in the previous episode of our C-Show Space series. And now we have more data about them from another one of Saturn's big moons, Oberon. Oberon is the outermost of Saturn's 5 large moons, and like all of Saturn's large moons, it's irregularly shaped. Unlike Titan, though, Oberon is only about 600 kilometers across, so it's more like the size of Earth's moon than Titan. And for most of us, Oberon is probably best known as the moon that has the largest known impact crater in the solar system, which is named after the Celtic god of death and the underworld because it sure does look like something from Mordor. But in 2019, when NASA's Cassini spacecraft performed its final orbits around Saturn before being intentionally crashed into the planet, it revealed some weird bright spots on Oberon's surface during its many close flybys. Scientists think these bright spots could be ice that's recently erupted onto the surface. But if that's true, does that mean Oberon once had, or maybe even still has, activity going on beneath its icy shell? Let's dig into this. When Cassini began orbiting Saturn in 2004, scientists thought that Oberon was just a big hunk of rock and ice left over from the early days of the solar system. It's so far out from the action, they figured it would have been pretty dead for billions of years. But then Cassini got up close and personal with the moon during its final orbits, revealing that Oberon has a bunch of mysterious bright spots. Now, we don't actually have any images of these features. These are just spots where the ground beneath reflected more light than expected. The team that found these features suggested that they might be cryovolcanoes, places where liquid water erupted onto the surface and froze almost instantly, leaving behind a deposit of fresh ice. That's a fancy way of saying that this moon is kind of erupting, but not really, because nothing's hot enough to melt rock. So instead of magma, it's water and other volatiles like ammonia that are erupting. We've seen evidence of cryovolcanism on other moons in the solar system, including on Jupiter's moon Europa and Neptune's moon Triton. So it seemed totally reasonable to suggest that Oberon might be cryovolcanic as well. But the problem with this hypothesis is that we'd expect the erupted ice to be pretty reflective, not just in visible light, but also in infrared. And Oberon's infrared data doesn't match up, so either these features are unmade of ice, or something is covering the ice with something less reflective. On top of that, there were two mysteries. 1. Why should there be cryovolcanoes on a dead, distant moon? And 2. What the heck is happening on Oberon? To answer those questions, we need to figure out how these spots formed and what they're made of. In 2023, a paper published in Nature Astronomy took a closer look at Oberon's mysterious bright spots. In addition to Oberon, Cassini visited another of Saturn's moons, Iapetus, that same year. On Iapetus, Cassini saw similar bright spots, but by analyzing the differences between how much light was reflected on Iapetus versus how much was reflected on Oberon, researchers were able to determine that these features couldn't just be pure ice. Instead, they must have some sort of dark material mixed in. And by figuring out how much of each color of light was being absorbed or reflected by the surface, researchers were able to figure out that this mysterious material has a bunch of water ice mixed with thalanite. Thalanite is a dark silicate mineral that forms when asteroids made of rock and dust get zapped by cosmic rays. It's common in space, but usually it's mixed with other materials that reflect more light. So normally it's pretty dark, not shiny. So the team concluded that these bright spots are probably made of thalanitrich material, that's mixed with a lot of ice, which is unusual because typically thalanite is only found mixed with dark materials. Then in 2023, scientists analyzed data from Cassini's final flyby of Oberon. They wanted to understand how the shiny material changed as it moved through Oberon's thin atmosphere. As the material moved through the atmosphere, it absorbed more and more ultraviolet light until it reached the surface. But then something unexpected happened. Normally, when material hits a surface, it bounces back, and you can see it better. But on Oberon, the researchers saw a decrease in light as it hit the surface, suggesting that the material actually disappeared into the surface. This means that Oberon has a porous surface, and that this material was filling up holes in Oberon's crust. And because the material is shiny and reflective, it means it's fairly fresh. The paper's authors estimate that it's no more than 200 million years old. For comparison, Earth's moon is 4.5 billion years old. Finally, by looking at the shape of the craters near these features, researchers could tell that they weren't caused by impacts, but instead by some kind of eruption. All of this data together paints a picture of Oberon that's a lot different from the lifeless moon scientists thought it was. Oberon has a porous surface full of ice and thalanite. But where did it come from, and why? Well, according to the research team, these features are most likely evidence of past interior activity. If Oberon is still kind of alive, that would make it unique among Saturn's large moons. That's because the main ingredients of these bright spots, water and thalanite, are both produced deep in Oberon's interior. Now, Oberon is so small that it never had the kind of internal heat that Earth has, which comes from the decay of radioactive elements in our planet's core. But it could have had a bunch of heat early in its life. Like if it had been warm when it formed, or if it had experienced some giant impacts early in the solar system's history. The decay of that initial heat, combined with the pressure of the weight of the moon, could have led to water ice forming deep under the surface and mixing with thalanite-rich material that had been pushed up by impacts. Then when big rocks rained down on Oberon late in the moon's history, it could have punched through the crust, releasing that water ice and forming the cryovolcanic features we see today. The real question is, could Oberon still have some of this volatile material left? Is it still generating enough heat to keep water ice under the surface? The team didn't have enough data to say for sure, but Oberon may not be done erupting just yet. This discovery raises a lot of questions about how moons evolve and how active they can stay for billions of years. And it shows us that even the cold, dead moons of Saturn could have a lot more going on than meets the eye. Thanks so much for watching and learning with us, and thanks to all of our patrons who help make it possible for everyone to learn about the amazing things happening in our universe. If you'd like to become a patron and get access to exclusive patron-only content, you can visit our website or click the join button in this video.